So transition curve. So what is transition curve, we will see. Suppose if you want to join two straight lines like this, two straight portions if you want to join, you can join with curve like this, circular curve, like this. Point O, point A, point B, this is the radius R. This is the intersection point. So you can join these two straight lines like this. Okay. Now our road is this one. This pink colored one is the road. Okay. So if you want to provide like this, see in straight portion, we don't want any super elevation or extra widening. In straight portion, no super elevation is required, right? But in curved portion, we need super elevation. So super elevation, you know, the outer edge will be raised, right? Outer edge will be raised. But in straight portion, camber will be there. So straight portion, camber means road will be like this. Both side slope, okay? Some rainwater falls on the road, then it drains away from, on both sides, like this. So this is the cross-section straight portion. But in super elevated portion, in curved portion actually, it will be like this. Okay. Curved portion, okay? Road is like this. So at a single point A or at B, you cannot immediately shift from cambered section to, super elevated section, right? So cambered section will be there up to A point. So from A onwards, A to B, super elevation should be there. From B onwards, again cambered section should be there. So at a single point, we cannot shift from straight portion to, the cambered portion to super elevated portion, right? Okay, so what is the solution for this? Not only that, one more problem here is driver cannot turn the vehicle at point A instantaneously. So driver requires some time to turn the steering, okay? Immediately he cannot turn the steering. If he does or otherwise If we turn instantaneously, if it tries to turn instantaneously, a jerk will come. Okay, jerk will be there. Okay, so we don't want that jerk and all. Okay, passengers will feel discomfort. Okay, this causes discomfort to passengers. Okay, so we have three problems. I mean, we have already we explained two problems. One is super elevation cannot be implemented immediately. Driver cannot turn the steering, and third one, extra widening. Extra widening cannot be given suddenly. That means, suppose this is the straight portion, then curved portion means extra widening we need, right? So we cannot give like this. It cannot be given like this, right? So smoothly, gradually, we need to increase width from straight portion to curved portion width. Okay, curved portion width is more, straight portion width is less because of that extra widening. So that extra widening has to be given gradually, not instantaneously like this. So what is the solution for all these problems? Okay, solution for the above problems is provision of transition curve. Okay, provision of transition curve. Okay, by providing this transition curve, all these three problems can be addressed. So what is meant by transition curve means, now we'll see how to provide this straight portion. Suppose you have straight portion like this. Two straights are joining like this. Suppose these are the points, curve points, okay, starting and ending point. So instead of providing curve like this, or I will, okay, actually your curve portion is like this, but how to provide transition curve means that I will explain. Okay, something like this. So actually, this is transition curve. Transition curve. This is suppose this point actually these are AB suppose, then it is C D or otherwise C D E F. Okay, the CD portion is transition curve and EF portion also transition curve. Okay, so what is the specialty of transition curve? We will see. You can observe here curve portion. Here this curve portion, this actual circular curve is circular curve. So without transition curve means circular curve is AB. But now we are providing circular curve with this one only, D only. Circular curve is now D only. So we are not providing this AB curve. We are providing circular curve of D only. The curve length decreased, right? Curve length decreased. Not only that, curve shifts inside. This is the called shifting. S is shift. Shift of the circular curve. How much it shifts and all we'll calculate, okay? So the curve length decreased as well as it shifts inside, okay? That is one thing. And we are providing this transition curve. What is the transition curve? What its importance and all we will see. See, function of transition curve is like this. Functions of transition curve. You know, the radius of straight portion is what? The radius of straight line is how much? Straight line radius. Infinity, right? Srinivas?
Yes, sir.
Yeah, radius of straight line is infinity. The radius of circular curve is finite. Some radius will be there, right? So the radius infinity to finite, suddenly it should not be changed. That's why to change the radius from infinity to finite value, transition curve is required. So I will explain you with one example. Suppose take this spiral. What is the property of spiral? Radius keep on. Radius is keep on what? Increasing, right? In spiral, radius increases from inside to outside. Radius increases, right? So in our case, if you take a part of the spiral, what happens? See, part of the spiral means suppose something like this. One part of the spiral. Suppose here very high radius, then radius decreased, then again radius decreases, then again radius decreases. So the property of this transition curve is radius decreases from infinity to finite. Okay, so in transition curve, radius decreases from infinity to finite. Okay, so what is the advantage of it? Why to provide like this? Why to decrease that radius from infinity to finite here means, you know the centrifugal force. Centrifugal force mv square by r varies from, see, r is infinity means 0 at infinity radius. Okay, from 0 to finite value. So varies from 0 to finite value. So centrifugal force has to be introduced gradually. That is, centrifugal force has to be introduced gradually, not suddenly. Okay, not suddenly, which causes jerk. If you don't provide any transition curve, the passengers will experience a jerk. Okay, because of sudden, sudden introduction of centrifugal force. So centrifugal force needs to be introduced gradually. Okay, to introduce centrifugal force gradually, we need transition curve. In which the radius decreases gradually. So in transition curve, radius decreases gradually so that centrifugal force will be introduced gradually. As radius decreases, centrifugal force increases, right? So that centrifugal force will be introduced gradually. The passengers won't experience any discomfort. Okay, so gradually that centrifugal force will be introduced so that the passengers may not feel any discomfort. So this is the main function of this transition curve. Second thing, that is first one. Second thing, super elevation and extra widening. Needs to be introduced gradually. That means first cambered section will be like this. Then gradually in transition curve, the cambered section, see this portion, in next stage it may go like this, in next stage it may go like this, next stage it goes like this, and finally super elevation will be introduced like this. Okay, the cambered section will be changed to super elevated section like this gradually, or in some other fashion also you can do. The rotation may be 1 second. Here rotation may be, see here rotation is from inner edge. This is inner edge. Rotation may be from center. That means gradually this edge will be decreased and this edge will be increased. Like this. So this edge will be, inner edge will be dropping and outer edge will be rising. So you can introduce, it is rotation is about center. Rotation is about center. Here rotation is about inner edge. మీకు అర్థమైంది కదా రొటేషన్ అంటే క్యాంబర్డ్ సెక్షన్ హౌ ఇట్ ఈస్ చేంజింగ్ ఫ్రమ్ క్యాంబర్డ్ సెక్షన్ టు సూపర్ ఎలివేటెడ్ సెక్షన్. సో ఈ ట్రాన్సిషన్ కర్వ్ లో గ్రాడ్యువల్ గా చేంజ్ చేసుకుంటూ పోతాం అనమాట. I will explain you in detail. Suppose this is the straight portion. From here transition curve starts. From here curved portion will be there. Okay, this is straight, this is curved, this is transition curve. Transition. Suppose if you take a cross section here, section 1, so road cross section is like this, camber at 1. Let us take at 2, second section. Little bit raised, okay. Let us take third section somewhere here. Still raised. Okay, gradually increasing. Okay, let us take final section here, fourth section. Okay, completely whatever rise is required, E into B, that will be raised. B width means, that means suppose here, suppose you need some 6 degrees here, here it may be 5 degrees, here it may be 3 degrees, like this. Gradually super elevation will be increased from this straight portion, this one, so 1 to 4, how it changes you can observe here. Okay, super elevation, not only super elevation, this extra widening you can observe here, extra widening also will be increased. Actually I will show you. Gradually the extra widening is increasing like this. Gradually from there onwards the extra widening is constant. From there onwards extra widening is constant, right? So the extra widening as well as, see this is the extra widening, both sides if you provide by 2 by 2, extra widening by 2, so both sides we are attaining, instead of giving extra widening suddenly, you are giving this extra widening gradually from straight portion to curved portion in transition region. So this is also a main function of transition curve. Okay, so first starting, actually first point what we have discussed, centrifugal force introduction is important. How to introduce centrifugal force? Okay, so mv square by r actually radius of the curve. So suddenly you cannot give centrifugal force, so you'll experience jerk actually. To avoid that jerk kind of things, so gradually we need to give centrifugal force. Second one is super elevation cannot be given suddenly, that means one step kind of thing will be there. at the road. Step will be there. Suddenly, camber section changed to super elevated section means you can observe a step on the road. So a vehicle cannot step up easily, right? So that's why gradually we are introducing that super elevation, and of course extra widening also. So these are the main functions of transition curve. Okay. Next, how much length needs to be provided? This transition curve length, how much it is required? This is very important. In GATE exam, you can get this kind of question. Okay. Length of transition curve. Length of transition curve. Okay. See, what is the centrifugal force? Centrifugal acceleration is how much? Centrifugal force. Force we will get from acceleration only. Mass into acceleration is force. So centrifugal acceleration is, you know, V square by R is the centrifugal acceleration. This acceleration cannot be given suddenly. So gradually we need to give. Suppose let L is the, or LS, L suffix S is the length of transition curve. The time taken for the vehicle to negotiate the transition curve is how much? So length is there, velocity is there. Velocity is V. Length to velocity. How you get time? Time. Velocity is meter per second. Length is meters. So length by V. LS by V, right? LS by V. Time taken is LS by V. Length by speed, because length is meters by meters per second. So you'll get seconds, right? So if you provide LS length, you'll have this time. Okay, this much time, LS by V time to travel on the transition curve. Okay, now this is T means. So rate of introduction of centrifugal acceleration or centrifugal force. Centrifugal force equal to now rate. So our centrifugal acceleration. Centrifugal acceleration. See, rate means by time. That is, actually, this is represented by C. Actually, C equal to here. Rate means acceleration, centrifugal acceleration, V square by R divided by time. Okay, V square by R divided by time. See, V square by R is centrifugal acceleration. By time means per second how much centrifugal acceleration can be introduced. Okay, C is nothing but per second. Rate means what? Per second. In 1 second, how much centrifugal acceleration can be introduced without feeling any discomfort, without causing any discomfort. So that is the C value. The rate of introduction of centrifugal acceleration C is V square by R by T, which is equal to V square by R by T is what? LS by V. So now that is equal to C equal to V square by R multiplied by V by LS. So that is V cube by R into LS. Otherwise, LS equal to V cube by CR. So this is the length of transition curve required. here C value basically varies from 0.5 to 0.8 meter per second cube, right? See, centrifugal acceleration is meter per second square, by time means meter per second cube. So this C value varies from 0.5 to 0.8 generally. Least is 0.5, highest is 0.8. So one empirical formula is there for C value. That is how, what is that, Kalyani?
80 by 75 plus V, sir.
Yeah, 80 by 75 plus capital V here, okay, where V is in kmph. But lower limit is 0.5, upper limit is 0.8. You should restrict that value to in between of this 0.5 to 0.8 only. If you get less than 0.5, you can take 0.5. If you get more than 0.8, upper limit, you can restrict to 0.8. This is the C value. So based on this, okay, this is comfort condition actually. So this is A for comfort condition. For comfort condition, okay. So based on comfort condition, we need to design length of transition curve. Next, second one, B, based on rate of introduction of super elevation. So how to arrive this, length of transition curve based on this? What is the rate of introduction of super elevation? Suppose actually super elevation suppose super elevation for suppose for B width, how much? B width is B into E, right? B into E. Example, for example, for 10 meters width, if E equal to 0.07, then super elevation required is how much? Outer rise 10 into 0.07, that equal to 0.7 meters. Okay, so 0.7 meters rise is required if rate of introduction of super elevation is suppose is 1 in n. Example, 1 in 100. Suppose it is 1 in 100. That means it means to introduce 1 meter super elevation, the length of transition curve required is transition curve required is 100 meters. So with 100 meters length, we can introduce 1 meter super elevation. Okay. So now, so to introduce 0.7 meters, how much is required? So to introduce 0.7 meter super elevation, length required is length of transition curve required is how much? See, for 1 meter rise, 100 meters is required. For 0.7 meter rise, how much is required? Kiran?
70 meters.
Yeah, exactly. 70 meters is enough. So now you tell me, if road width at curve is width plus extra width, right? Both will be there at curve. If road width at curve is W plus WE and rate of introduction of superelevation is 1 in n, then the length required is, the length of transition curve is LS equal to, you see what we did here, 10 into 0.7, 10 into 0.07, we got 0.7 meters. Okay, that 0.7 into 100, we got 70 meters. So what we are multiplying here, width and superelevation we are multiplying, and again that is multiplying with the n, then only you are getting length, right? 10 into, see, this 10 is what, the width of the road, this 0.07 is what, superelevation, this 100 is what, n, 1 in n means that is 100 is n. Here LS is nothing but, now see, width is W plus WE here, W plus WE, and superelevation is E, and n, 1 in n is the rate of introduction of superelevation, then into n should be multiplied. Okay, like this. See here, if superelevation is, if superelevation is provided by rotating about, by rotation about, by rotation about center of the road, so then what we need to do, here 50%, here 50%. So here the rise is what, W plus WE into E by 2. Here drop is W plus WE into E by 2. Okay, so rise is 50%, drop is 50%, then the length of transition curve required is LS equal to W plus WE into E by 2 into n, that is n whole divided by 2. So 50% of length is enough. If rotation is about center of the road, then 50% of previous is enough. Okay, previous case, this is here, rotation is about inner edge. Okay, if rotation is about center of the road, then 50% is enough. W plus WE into E into n. Okay, then finally case 3, C. See, based on, first one is based on centrifugal acceleration or comfort condition. Second one is based on introduction of superelevation. Third one is IRC recommended formula. IRC recommended formula in plain and rolling terrain, LS, minimum LS required is 2.7 V square by R. Okay, where V is in kmph, empirical formula. Okay, in mountainous and steep terrains, LS equal to V square by R. Okay. So these three things we need to remember. One is comfort condition, second one is supervision point of view, third one is IRC recommended formula. N value can be assumed in between of 120 to 150. Okay, based on practical conditions, you can go for 120 to 150 recommended value. Okay. So let us work out some problems. Find the length of transition curve required for the curve of radius 360 meters and design speed of 100 kmph based on comfort condition. Okay, assume the rate of change of centrifugal acceleration as per IRC code. Okay, so this is the question. So as per IRC code, you know, 80 by 75 plus V, which is equal to 80 by 75 plus V is 100, equal to 80 by 75 plus 100. 0.457. Actually, C should be restricted between, C is in between of 0.5 and 0.8. So take C equal to 0.5. So it is getting less than 0.5. So we need to take 0.5. So now we have, so formula LS equal to V cube by CR. Okay. So V is 100 by 3.6 cube divided by C 0.5 or radius 360, which is equal to 100 by 3.6 cube by 0.5 into 360, 119.07 meters, like this. Okay. Next. Find the length of transition curve for a circular curve of radius 250 meters based on, okay, based on centrifugal acceleration consideration. Assume the rate of change of centrifugal acceleration is 0.6 meter per second cube. Okay. The design speed of road is design speed of road is 80 kmph. Okay. So now directly LS equal to V cube by CR, which equal to 80 is the speed by 3.6 cube by C given directly 0.6 into radius 250 meters. That equal to you will get in meters. So 80 by 3.6 cube
73.16.
by 0.6 into 250, 73.16. 73.16 meters. Okay. Next. Find the length of transition curve based on superelevation requirement. Superelevation requirement for the following data. Number of lanes 2. Length of wheelbase 7 meters. Width of each lane in straight portion 3.5 meter. Radius of curve, radius of circular curve equal to 400 meters. Design speed 100 kmph. Rate of introduction of superelevation equal to 1 in 120. Superelevation is superelevation equal to 6%. Okay. The rotation is about inner edge. This is the data. Okay. So we need to solve. Okay, now. So formula length of curve equal to here, length of transition curve equal to W plus WE into E into N. So we have here W equal to straight portion width equal to 2 lanes are there, each lane 3.5 into 2, that equal to 7 meters. Extra width equal to NL square by 2R plus V by 9.5 root R, right? N number of lanes 2 lanes, L wheelbase 7 square by 2 into radius of the curve is 400 meters plus V design speed 100 kmph by 9.5 root 400, which is equal to 2 into 49.
Sir,
100. Yes, ma.
రేడియస్ ఆఫ్ కర్వ్ అనేది 300 కంటే ఎక్కువ ఉంటే మనం ఎక్స్ట్రా వైడనింగ్ ప్రొవైడ్ చేయము కదా సార్.
ఎవరమ్మా చెప్పింది?
కళ్యాణి సార్.
ఎందుకమ్మా, ఎందుకు ప్రొవైడ్ చేయమమ్మా?
అంటే సర్టెన్ వాల్యూస్ ఉంటాయి కదా సార్ మనకి, 50 కన్నా తక్కువ, అంటే తక్కువ ఉన్నా అని 300 కంటే ఎక్కువ ఉన్నా అని ప్రొవైడ్ చేయము అని చదివాను సార్ నేను.
ఎక్కడ చదివామ్మా? పంపించమా నాకు తర్వాత.
ఓకే సార్.
So it is extra widening is here 0.648. That means 65, right? 0.65 meters is the extra widening. Now substituting in formula, that is LS equal to W7 plus 0.65 into E 6%, that means 0.06 into N. N is here 120. That equal to 7 plus 0.65 into 0.06 into 120. That is 55.08 meters is the transition curve length required. Okay. Next, find the transition curve length based on IRC formula. IRC formula for the following data. For the following data, radius of curve equal to suppose 300 meters. Terrain is plain terrain. Design speed 80 kmph. Okay, so it is direct formula. LS equal to 2.7 V square by R. V is in kmph. Okay, 2.7 V square 80 square by R 300 equal to 2.7 into 80 square by 300, 57.6 meters, like this. Okay. Next step. Find the length of transition curve required for a circular curve of radius 120 meters in steep terrain. Use IRC code formula. Design speed is 50 kmph. Okay, so as terrain is steep terrain, so LS formula V square by R. That means V 50 square by R is here 120. T square by 120. V square by R 20.83 meters. Okay.